Hello, I'm Richard Patterson, and I'd like to welcome you to another demonstration presented by IPC Irwin. And in this episode, we're going to look at the Xenon Stroboscope. Now, the stroboscope has at the front of it a discharge tube filled with the inert gas xenon, and a timing circuit provides a pulse of electricity which causes the xenon tube to emit a flash of light. Now, because we've got an accurate timer in here, I'll turn around and show you the rear panel. We can use the flashing rate very accurately. So we'll just look at the controls, and we've got a rock switch down, a standard mains connector, and this control allows us to adjust the flash rate. So it will go from between 1 and 10 flashes per second, 10 to 100, or 100 up to 250. And you can adjust the flash rate with this control here as well. And there'll be a readout of the flash rate on this panel. I'll just connect it. And it makes a kind of buzzing noise. And that's the internal circuit and the tube flashing away. Now, for more advanced work, we've got a couple of ports there so we can externally trigger it, but we'll look at those in another episode. So you want the trigger control on internal. So if I turn it round again, you can see it's giving out quite intense white light. And again, if we turn it down to the lowest rate, you can probably see that that's flashing. Now, before we use this as a demonstration, it's important to know about the safety side of this. Teachers must be aware that any student suffering from photo-induced epilepsy could be affected by this. Now, it's a very rare condition, but you need to take account of it. The frequency range between 7 and 15 hertz is the critical one, and we can't get away from that frequency range when we're doing experiments with it. So if you just carefully find out subtly if there's anyone affected by this, and they can either leave the room or shield their eyes when the equipment's working. So why would you need this piece of equipment, the Xenon Stroboscope? Well, if we have any experiments where something's moving rapidly, we can actually freeze the motion and take some measurements. So we're talking about dynamics experiments where we have something moving down a track, or we might have something moving periodically, something oscillating, such as a vibrating string or wire, and we want to look at standing waves, resonance, that type of thing. And finally, if we want to look at the speed and frequency of anything, again, this flashing light can freeze that motion. And for junior and lower senior school science, we're talking about, for example, the ripple tank. We might want to freeze the waves moving across the water. So I'm going to use the stroboscope now to see how we can freeze the motion of this little orange fan driven by a motor in this box here. So I'll switch the fan on and it will rotate continuously, and I've placed a tiny piece of blue tack on one of the blades there. I've put a rheostat in series here so we've got fine control of the motor. Now you can do this with any moving machinery in your lab. If you've got any old motor there that runs consistently, you can try this out. So we'll switch on the stroboscope, and now if we get the rate of flash at just the right point, we should see the fan blade and its white piece of blue tack stationary. So I'm just adjusting the fan, the flash speed there, and I hope you can see now that the blades of the fan appear stationary there. So stroboscopes are very useful for checking the timing of machinery like car engines, and if you've got a vinyl record player deck, you can also check they're running at the correct number of revolutions per minute using a little stroboscope. In later episodes, we'll use the stroboscope to illuminate water waves moving in the IPC Irwin ripple tank. And as you can see in this graphic, we have the stroboscope mounted vertically above the ripple tank. It shines down through the water, and the wavefronts are reflected onto a card below. Now, we can freeze the motion of the waves and use a ruler to measure the wavelength of the waves and work out, using the flash rate, what the wave speed will be. As usual, we have a QR code coming up now, and if you use that, you can get to the IPC Irwin website for setup and product details for our extensive teaching notes. We've also included the IOP Spark practical notes as well, where you can follow up more experiments using the stroboscope. And also we've put the CLEAP site for full safety instructions on using stroboscopes in school.